Solving systems using the addition method, otherwise known as the elimination method or subtraction method. There are multiple different ways to do this. So it's also elimination and subtraction method. So we're just going to go through a bunch of examples of this. In this problem here, the addition method is I turn my two equations, I line them up, as I have done here. I have x plus y is equal to 5 and x minus y is equal to 1. So, and I turn it into a big addition problem. So x plus x is equal to 2x. Y plus negative y is equal to 0. And 5 plus 1 is equal to 6. So I'm now going to divide by 2 on both sides, and I get x is equal to 3. But I'm not done yet because I need to solve for my y. So x plus 3 plus y is equal to 5. So y must equal 2. So my final answer is 3, 2. Let's try this again. Now if I turn this into a big addition problem, I can't cancel anything out because x plus x will make 3x and 3y plus 3y will make 6y. So nothing cancels out. And my goal is to cancel something out. So a variable. So what I could do is either make this a subtraction problem, but I have a hard time usually remembering that. I always like to do addition problems, so I'm going to multiply this entire bottom by a negative 1. So my new equation is going to be x plus 3y is equal to 8. I didn't change the top at all. But now I'll have negative x minus 3y is equal to negative 7. Because all I did was multiply everybody by a negative. So now I'm going to again go to my addition, and notice my y's now will go away. So 2x minus x is just x. Those cancel, equals 1. So I know x is equal to 1. Now I'll plug it back in. And I'm going to plug this one back into the top one. 2 times 1 plus 3y is equal to 8. So 3y is equal to, and I'm going to subtract that 2, 6. So y is equal to 2. So my point is 1, 2, where they meet at. So let's try this again. See if we can cancel anything out. If I turn this into an addition problem, nothing goes away. If I turn this into a subtraction problem right away, nothing goes away. So now I have to look to see, do I have any common factors that, can I multiply the top by something or the bottom by something to cancel it out? Well, I notice that I can multiply this bottom by 3, and it will turn this into a 6 right there. And that's exactly what I want, to be able to get a 6. So I leave the top alone. 3x plus 6y is equal to negative 6. But now I have 15x minus 6y is equal to 42. Yes. So now I go to make my addition problem, and I end up with 18x. Those go away, is equal to 36. Divide by 18, and x is equal to 2. I got my x equal to 2, so 3 times 2 plus 6y is equal to negative 6. 6 plus 6y is equal to negative 6. Whew. Divide by it, or subtract 6 from both sides, I get 6y is equal to negative 12. Divide by 6, y is equal to negative 2. So my final answer is 2, negative 2. Alright, last one here. We're going to put this all together. So notice, let's see, we have 6x plus 2y is equal to 4, and 10x plus 7y is equal to negative 8. Now, if I multiply the top by anything, if I multiply 6 by anything, can I get 10? No. How about 2 by anything to get 7? No. Can I multiply 10 by anything to get 6? 7 to get 2? No. So now what we have to do is come up with a common factor, or common multiple of theirs. So what I'm going to do is multiply the top by 7 and the bottom by actually a negative 2. So that way I have one value that's negative and one value that's positive. So when I multiply the top by 7, I end up with 42x plus 14y is equal to 28. And I multiply the bottom by 2, and I get negative 20x minus 14y is equal to 16. So notice I've now made it so I can cancel out my y's. So I just multiplied the top by the whatever number I had here and the bottom by the number I had up top. So when I go to subtract, I end up with, or add, I end up with 22x is equal to 12. From here I divide and I get x is equal to 12 over 22, which is also 6 over 11. Alright, so I'm not done yet though. I need to go back in and solve for my y variable. So 6 times 6 over 11, we're not going to have a pretty number, plus 2y is equal to 4. So we're going to end up with 36 over 11 plus 2y is equal to 4. Oof. So I'm actually going to make the 4 over 11 too. So 2y is equal to 44 over 11, because I multiplied top and bottom by 11, minus 36 over 11. So 44, 2y is equal to 8 over 11. Divide by 2. Divide this all by 2, or multiply by 1/2. And I get 4 over 11 is what y equals. So my point is 6 over 11, comma, 4 over 11. And that ends our bit on solving systems algebraically.